Hello and welcome back to Ganesh Institute. So in today's video, we are taking up another topic from solving differential equations, and that is what are homogeneous differential equations and how can we solve those. So firstly, what are homogeneous differential equation? So you know homo means same. So what is going to be same here? So here those equations where each term has same degree. For example, I have a differential coefficient and it is in the form of two terms, two function fxy or phi xy. So if its degree is 2, then it has to be, denominator's degree has to be 2 as well. So you will say that these are homogeneous differential equation. Now you cannot do them with separation of variables form or method. First you have to make them in the form that variables can be separated. How? Let's see. We have a question where you need to solve x squared dy plus y x plus y dx equals 0. Okay, so in that case you can see, first up, find out dy by dx or dx by dy, whichever way you can. So I'm keeping x squared dy here and I'm putting onto the right hand side, taking this term onto the right hand side. Okay, now dy, I'm bringing this dx down onto the left hand side, and here is this x square onto the right hand side. Okay, now you can see that if I expand this expression, this is minus xy minus y square by x square, correct? So what is its form? This is actually, you can see, this term has degree 2, this has degree 2. So when variables are in multiplication, you collectively tell that 1 1 2 is the degree for this term, and in denominator also degree is 2. So yes, we will say that it is a homogeneous differential equation, and whenever it is homogeneous differential equation of the type dy by dx, then you have to substitute before separating the variables, because at the moment variables cannot be separated. Okay, so you have to assume that y is equals to vx. If it would have been dx by dy, then you were supposed to assume x is equals to vy. Okay, now you are considering y vx. Now differentiate it. So dy by dx, if you apply product rule here, differentiation of v with the rest, v is constant, so differentiation of x is 1, plus you are keeping x as it is and differentiation of v with respect to x. So this is the expansion, right? This is first, this is second. So on putting second into first, what have we got? So v plus x dv by dx. This is dy by dx. So I have put it here, this whole terminology here. And now I'm placing y as vx. I'm placing vx in place of y. Okay, so let's do it. Here equals minus xy. So x, y is according to our assumption vx, minus y square, that is vx whole square, divided by x square. Now v plus x dv by dx equals, this is vx square minus v square x square divided by x square. So v plus x dv by dx has become, now if I take this as common, x square, what's left? Minus v minus v square, right? This got cancelled. X dv by dx minus v square, x dv by dx here, minus v this v on the right hand side. So you've got x dv by dx equals minus v square minus 2v. Now can you separate the variables? Yes, now variables can be separated. So on separating the variables and then integrating them, we know how to do it. And then integrating. Okay, so dv is here. I'm bringing this down, minus v square minus 2v. And this is dx by x. Okay, I can make it plus also by keeping it minus. Correct? So what can be done now? You can see that we have dv upon v square plus 2v. This has to be done by, if you want to integrate, this is simple, 1 by x is log x. But for this here, we have to apply partial fraction. It is v plus 2, correct? So you can assume it as a upon v plus b upon v plus 2. Okay, by parts you have to do it. Alright, now find out the values for a and b by comparing. So it is 1. Here if you cross multiply, this is a into v plus 2 plus bv. 1 equals, this is av plus 2a plus bv. 1 v can be taken out as common for these two plus 2a. Now on the left hand side, can you see coefficient of v is what? 0. So on comparing coefficients of v, a plus b is 0, and on comparing constant terms, 2a is 1. So a becomes 1 by 2, and here if I substitute the value of a, b becomes minus 1 by 2. So on putting the values here and then to this question, a by v, a by v means 1 by 2 v, yes, and then b is minus 1 by 2. Next part is what? V plus 2 and right hand side is what? Minus dx by x. Right? Now it's simple. You can differentiate. So 1 by 2 log v minus, this is also 1, if you can assume 1 by x. So 1 by 2 again log v plus 2, and this is minus log x. Either you can consider the value of c as log c or only c, that depends on you. So now you can see that if I can take this 1 by 2 common and take it to the right hand side. So log v minus log v plus 2 is equals to minus 2 log x plus 2c, right? Now whenever log a minus log b is given, we can write it in the form of division, and this is the power. I can take the coefficient as power plus 2c. Then I can bring logs together, and because it is in plus form, I can write it as what? Multiplication. So it will become vx square by v plus 2, and this is 2c, right? If you want, you can consider this 2c as log c or log p or log a, whatever. Correct? Where 2c is log a. In case you want to consider the whole thing in the log form, so it's easy now. Log gets cancelled and vx square by v plus 2 is equal to a. And what's the value of v? we had assumed that y is equals to vx. So v is what? Y by x. So if I put back this value, y by x plus 2. Yeah, I have placed here y by x is equals to a. So x is cancelled with x, so this is xy. Now if you take the LCM, it's x, and y plus 2x equals a. This x goes into numerator, so x square y, and this is what? Y plus 2x can be taken onto the right hand side, so it becomes 2x plus y, and this is our solved homogeneous differential equation. I'm hoping that you've got this idea that in order to separate the variables, we firstly in homogeneous form we have to assume something so that variables can be separated. If you got this concept right, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.